Here's a video for lesson 33, solving group work word problems. Now, the general steps for solving a word problem in mathematics involve A, reading, then we identify any important information, and we create a variable for the unknown that usually becomes our x. Now, these type of word problems that result in rational equations, meaning fractions with equal signs, and that's what makes an equation an equal sign. So they're fractions, and there's an equal sign. Now, they usually have to deal with rates over time or ratios. We're going to be dealing specifically with rates over time for right now. I'm going to do two questions. They're very similar. Some of them are working together, some of them are working against each other, and I'm going to do one of each for you. They follow the similar flow. I'm going to do question 7. Coach Grant says the boys' team has to practice until they score 220 free throws. Nicholas could make 220 free throws in 50 minutes, and Isaiah can do it in 60. How long will it take them if they work together? Well, since they're working together, their efforts are being added. So we essentially have two people participating here. We have Nick plus Isaiah equals the total. And what we're dealing with here is we're dealing with their rates. So it's Nick's rate plus Isaiah's rate equals the total rate. Now, what can Nick do? The format that we typically use for this is, and I'll write this out and then I'll delete it. This is a general flow. The fractions are always going to be what can they/it do and over how much time does it take. So in this case, Nick's rate is that he can do 220 free throws over 50 minutes. Now we need to add Isaiah in here. Isaiah can do 220 free throws over 60 minutes. And now combined, they're still going to be scoring 220 free throws. We just don't know how long it's going to take them. Once they finish their 220 free throws, Coach Grant will let them leave. But we don't know how long it's going to take them, so that's X minutes. Now let me take out the units and rewrite this. So what do I really have as far as the numbers go? I've got 220 over 50 plus 220 over 60 is equal to 220 over X. Now in order to solve a rational equation, we need common denominators. So what I think to myself is, okay, well, what multiples do we have? I'm thinking just to myself, 50, 100, 150, 200. None of those 60 goes into, so I'll keep going. 250, 300. Ah, yeah, so 60 could become 300, so that's the number I'll use. So if this was times 6, I would have times 6 on the top as well. In order to make this into 300, I would have to multiply by 5. That would need 5 on top as well. And now this has an x. Well, the left side's missing an x, so I'm going to put the x in there. And the right side is missing a 300. So now let's see, 6 times 50x, 5 times 60x, and 300x. Those are all the same thing. Those are all equal. And since they're all equal, I can cross them out. My new equation is just the numerators. So let's see, 6 times 220x. I might want a little on-screen calculator for this. Let me pop that up. So 6 times 220 is 1320. So I have 1320x plus 5 times 220, let's see, is 1100 x's. On the right hand side, 300 times 220, definitely want a calculator for that, is 66,000. I'm going to combine these on the left, 1320 plus 1100, that's going to be 2420 x's is equal to 66,000. And now I just need to divide by the coefficient, 2420, on both sides. (27.27). So x equals 27.3. What were my units? Let's look back at the original question. Minutes. X minutes. So 27.3 minutes. So that's how long it would take them to complete it together. And if you think about it, that makes sense. Isaiah would take an hour, Nick would take 50 minutes. If they work together, it should take them shorter. Yep, 27.3 minutes makes sense. So that's what you always do when they're working together. One rate plus the other rate plus a third rate if there's 3 people working together, etc., all equals the total. And your time is always in the denominator. Time is always the bottom. Now let's do one that's working against each other. Question 13. Finish Line has 2 employees attempting to keep the floor stocked with shoes on Black Friday. The employees are replenishing the entire floor once every 2.2 hours. And customers are purchasing shoes so quickly that it would take them 130 minutes to empty the sales floor. How long will it be until Finish Line sales floor is empty? Now, the first thing that I need to address here, thank goodness you have me, is that this is in hours and this is in minutes. I want them to all be in the same units. So what I'm going to do is I'm going to convert this. And I'll bring up my calculator to show you how. I want to circle that a little better. Okay, 2.2 hours. Well, there are 60 minutes in an hour. So what I'm going to do is I'm going to do 2.2 times 60. That should tell me how many minutes it is. 132 minutes. Now, this, given how close they are, is going to be a very big number because they're working at almost the same rate. 132 minutes and the other one is 130. Now, let's think about the relationship here. Finish Line, the employees are stocking the floor. That's positive. Okay, so the employees are positive. The customers are purchasing shoes so quickly that they can empty the sales floor. So the customers are negative. So let me think. So I've got employees minus, and I guess I could say employees rate, minus customer rate, equals the total rate. Now remember that it's the same thing like I said before. It's what? Like what are they doing over how long? What over how long? So what are the employees doing? They're restocking the floor. They're restocking one entire sales floor. I don't know how many pairs of shoes that is, so we're just going to call that one floor. Over how long? Well, it says it takes them 2.2 hours or 132 minutes. And bring down my minus sign. My customers, what are they doing? The customers are emptying. What are they emptying? What are they doing? Well, they're emptying one floor as well. My numerators and denominators should always be the same units anyway. Over. How long does it take them? It says 130 minutes. Equals the total. Together, combining their efforts, working against each other, we could do one floor in how many minutes? I don't know. We'll call that X. Now, I'm going to rewrite this just without the units, because I like to clean it up. So I've got 1 over 132 minus 1 over 130 equals 1 over X. I look at these two numbers, 130 and 132, and I don't know what their common denominator would be. I don't know what common multiple they have. So here's what I'm going to do. I'm going to say 130. Well, you know, let me just make that orange instead of scribbling over it, making it messy. I'm going to multiply that here. And I'm going to multiply that here. I'll make the 132 purple. Because I'm going to multiply that here and here. Now, whatever that number is, I'm definitely going to want a calculator for it, but I can be sure that these are the same thing. So let me see what that number is. $17,160. So essentially what I'm saying is that this is $17,160, this is $17,160, this is just X. So I'm going to need a $17,160 here and a $17,160 here, both attached with multiplication. I'm still missing an X. I don't have an X on the other two denominators, right? This X stands alone here. So this side needs an X and this one needs an X as well. So if I throw an X here and an X here, X here, and X here, it could go at the front or I could have put it at the end. It doesn't matter which side I put it on. But essentially now they all have the same denominator, 17,160x. So I can cross them out. Now let me clean this up. I'm going to hide this calculator, but I'm going to need it again in a second, I know. So let's see. 130x minus sign, still there. 132x equals 17,160. 130 minus 132 is going to be negative 2x equals 17,160. And in order to get x by itself, I'm going to have to divide by negative 2 on both sides. I knew I'd need that calculator. So 17,160 divided by negative 2 is equal to negative 8580. And remember that our goal was to solve for how many minutes it would take. So this is minutes. Now, does a negative time make sense? And since we've covered this in class, I know that you and I both know that it doesn't. So we'll ignore the negative, and we'll say that x equals 8,580 minutes. If you wanted to know how many hours that is, you could divide it by 60. 8580 divided by 60 will tell you that that is 143 hours. You're not responsible for converting this. I'm just doing it so you can get a handle on how big this number is. 143 hours. Let's think about how many days that is. 143 divided by 24. So that is almost 6 days, 5.95 days, 5.96 days. That'd be a very long time, so not too bad. All right, I hope that that helps. If you have any more questions, please feel free to see me in office hours. Good luck.